Hello, my name is Alex Danielov, and I'm here on behalf of the CLL Society. And with me here today is Dr. Arnon Kater. Dr. Kater, would you please introduce yourself?
Yeah, I'm Arnon Kater. I'm a hematologist here in Amsterdam, and I'm the chairman of the HOVEN CLL study group of the HOVEN.
Thank you, Dr. Kater, for joining us to discuss the abstract that you presented at ASH, which focused on the NKT cell engager LAVA 51 to target CD1D expressing CLL. Can you please briefly tell us what this study found?
Yeah, so maybe I should explain a little bit what we are doing here. What actually there's it's actually work based of a very good colleague of mine, Hans van der Vliet, who discovered, who experimented by activating not the normal T cells, but gamma delta T cells. And gamma delta T cells is a subtype of the T cells, so of the cells that normally act to fight your viruses, the T cells. And within those T cells, you have different types. And the gamma delta T cells are a special type. You have it's a low frequency, very well conserved during evolution. Those cells recognize a specific type of proteins or of antigens actually on a target cell, which are higher expressed on tumor cells than normal cells. This are called phosphoantigens. So phosphoantigens are on a normal cell very low, but in cancer cells they're higher, and the gamma delta T cell will recognize them, and if they recognize them, they get activated and will kill the target cell. So what have been made is in llamas, which is an animal model, we know llamas, right? But they make very small antibodies. So if you can in those animals, you can make very small fragments of antibodies called VHH. And those, the advantage is that they are, because they are so small, they are easy to manipulate, they're easy to manufacture, and they're easy to couple to other proteins, to other VHH molecules. So actually what was done is a target, but which appears on both AML and multiple myeloma and CLL, called CD1D, coupled to an to another fragment of this protein that actually activates the gamma delta T cells. And CD1D, which is the recognized and on the CLL cells, is also able to activate a third cell, which is an NKT cell, a very conserved group of cells that are having features of both normal T cells and NK cells. So it's quite a complex story, but the idea is that with a very small molecule, you can actually bind tumor cells to gamma delta T cells and activate your NKT cells. And the idea is that you can then develop a very specific immune response, while you hopefully have much less side effects than we have with the normal T cell therapies like CAR T cells or bispecific antibodies, which gives a lot of inflammation of the patients. So that's a bit the background of this idea, to have a more specific, more efficient killing of your cancer cells by specific T cells that hopefully do much less harm to the whole system. And what was presented at this conference was in vitro data showing indeed that with those gamma delta T cells, you can actually kill and inhibit your cancer cells that are CD1D positive. And there were preliminary data of a phase 1 study that is just started. So we are still at dose expansion phase. What I can say so far is that toxicities were very mild indeed, as I hoped, as expected. There might be also activity there, but I think it's too early to call exactly how much activity there is as one therapy. But so far, it's at least for toxicity profile, it looks very promising.
Well, that's fascinating, and of course, bispecific antibodies is becoming a big field in lymphoma and entering the CLL field. So, do you anticipate similar toxicities as we see with bispecifics, like cytokine release syndrome? Do you anticipate that lymphocytosis in some patients will be an impediment?
Yeah, so that's indeed the hope. So I also presented at the same ASH the first data on epcoritamab, which is a normal, say, CD3, CD20 antibody. The problem always has been that many groups, including ours, have studied extensively that T cells are less functional in the context of CLL, probably because of direct interactions between the cancer and the T cells. But we also could have shown in vitro at least that bispecific antibodies have a much seems to, at least for some extent, overcome this T cell dysfunction. So what we saw in patients so far is that also for epcoritamab and also for LAVA, that the toxicities were pretty okayish, nothing a grade 3 or higher, all grade 1 and 2. And for the epcoritamab, which is already at a much higher dose, is showing also preliminary activity with PRs and also CRs actually. So it looks very promising, but I think it's too early to really make a definite call there. But it all looks what we hoped it would look. Yeah.
Yeah. Well, thank you very much, Dr. Kater. This is really important and fascinating work. I agree with you. In the next few years, it actually might change lives of our patients once again.
Yes. Exactly.
All right. Thank you.